So good morning children. So today we are going to start the new topic, that is what regular and irregular polygon. So in our previous class we have learned what is curve and what are different type of curves, means what closed curve, open curve. Then we have learned about polygon. Okay. So polygon already you know that in the last class I told you polygons means what? Closed curve made up of what? Line segment. It's called polygon. Then after that we have discussed about what? Convex polygon and concave polygon. Convex polygons means what? If the diagonals of a polygon all the diagonals of a polygon lies inside the triangle, inside the polygon, then it is called a convex polygon. If all the diagonals of a polygon does not lies inside the polygon, then it is called a what? Concave polygon. And in class 8 level we will discuss about convex polygon only. Okay, so today we are going to discuss about regular and irregular polygon. So let us see what is regular and irregular polygon. Alright, regular and irregular polygon. Regular and irregular polygon. So let us discuss this one. Okay, so it means regular polygons means if all the sides of a polygon are equal. If all the sides of a polygon may be of different type: triangles, quadrilateral, hexagon, pentagon, decagon. Okay, these are the polygons. If all the sides of that polygons are what? Equal, then it is called a what? Regular polygon. And if all the sides are not equal, then it is called a what? Irregular polygon. Okay, so let us see what is. Let us try to write the definition of regular polygon. If all the sides of a polygon are equal, then such type of polygon, polygons are called regular polygon. Otherwise irregular. Otherwise irregular means if all the sides are not equal, then it is called irregular. Otherwise irregular. Alright. So I hope it is clear what is regular and irregular polygon. Yeah, regular polygons means if all the sides of polygons are equal, then such type of polygons are called what? Regular polygon. Otherwise irregular. If all the sides are not equal, then what type of polygon? Then that such type of polygons are called what? Irregular. So let us see some examples. Suppose this is a triangle. Okay. So all these three sides are equal here. This is one side, this is another side, this is another side. Let us say this is 3 centimeter, this is 3 centimeter, and this is also 3 centimeter. So you see here all the sides are equal here. Okay, so that's why it is called a what? Regular polygon. And name of that polygon is what? Triangle. So how you will use the symbol to show that all the sides are equal? You use this symbol. Suppose you see I am using the same symbol here. Okay, you see, means what these symbols indicate? These symbols indicates that all the sides of this polygon is what? Are what? Equal. Now let us take one more example. Okay, suppose this is also a polygon. And what is the name of this polygon? The name of this polygon is quadrilateral. Why? Because it has 4 sides. First of all, it is a polygon, and name of this polygon is quadrilateral. Here also all the sides are equal. Let us say 4 centimeter, 4 centimeter, 4 centimeter, 4 centimeter. So all the sides are equal. That's why it is called a what? Regular polygon. So the symbol to indicate that all sides are equal, like this you can use. Okay. So what these symbols indicate? These symbols same symbol we have to use everywhere because it shows that all the sides are what? Equal. Okay. So that is about what? Regular and irregular polygon. Okay, irregular polygon, in irregular polygon sides are not equal, and in regular polygon all sides are equal. Okay, so that is about what? Regular and irregular polygon. Okay, our next topic is what? Angle sum property. So let's just see what is the angle sum property. Now come to the exercise what 3.1. In exercise 3.1 you see some polygons are given. Okay. These are the 8 polygons are not polygons, sorry. Some diagrams are given here, and from the diagrams you have to classify them. Which are simple curve, which are simple closed curve, which are polygon, and which are convex polygon, and which are concave polygon. Now you see here the first curve. Simple curve. Remember this. What is simple curve? Without lifting the pen of the tip of the pencil or pen, whatever figure you will draw, that is called a curve. But remember, while drawing the figure, the lines should not be intersect. But then in that case, it is not a simple curve. The lines should not be what? Intersect with each other. When you are drawing the figure, it should not be intersect with each other. Then it is not a curve. Although without lifting the pencil you are drawing the figure, but it is not a simple curve. Okay, now let us see the first figure, whether it is simple curve or not. Okay, you see, without lifting the pencil I am drawing the figure. Okay, so it is a what? Simple curve. Yes, figure 1 is what? Simple curve. Now come to the figure 2. Without lifting I am drawing the figure. Yes, this is also a what? Simple curve. So 2 is also a simple curve. Now come to the figure number 3. You see figure number 3. Okay. This one. But for drawing this one I am lifting the what? Pencil. That's why it is not a what? A curve. Simple curve. Okay. Now come to figure number 4. Figure number 4 you see, if you draw this one without lifting the pencil you can draw it, but remember the lines are crossing with each other, that's why it is not a simple curve. Now come to this one. This figure can you draw without lifting the pencil? Yes, I can draw. Without lifting the pencil, yes, I can draw. So this is also a what? Simple curve. Then this figure. Okay, this figure also I can draw without lifting the pencil. So this is also a what? Simple curve. Figure number 6. Now come to figure number 7. Let us see whether it is a simple curve or not. You see, this one you can draw without lifting the what? Pencil. So that is also a what? Simple curve. So 7 is also a what? Simple curve. Clear? Is it clear to you? So figure number 1, figure number 2, figure number 5, figure number 6, figure number 7 are called what? Simple. These are simple curves. Now come to simple closed curve. These are closed. Simple curve plus closed also. Now you see this is a simple curve or not? Yes, this is a simple curve, but it is closed or open? It is closed. That's why figure number 1 is what? Simple closed curve. Figure number 2. This is also a what? Closed curve. Simple closed curve. Figure number 2. And figure number 3. It is not a simple curve. Okay, that's why no. Figure number 4. It is not a simple curve. And this one, figure number 5. You see, this is a simple curve plus it is a closed. So it is a closed, simple closed curve. 1, 2, and figure number 5, and figure number 6. It is a closed plus it is a what? Curve. So it is a closed curve. So figure number 6. Then this one. This is a what? Simple curve, and you see it is a closed. So this is a closed curve. So 7, and it is not a simple curve also. That's why it is simple, and this is not a simple closed curve. Now come to polygon. Which are the which figures are what? Polygons here. All right. Now polygons means closed curve that is made up of line segment. Closed curve that is made up of what? Line segment are called what? Polygon. So now here what are which are polygon? You see, this is a closed curve, and this closed curve is made up of what? Line segment. It is a polygon. So figure number 1. This is also a polygon. You see, this is a closed curve, and these are this closed curve made up of what? Line segment. So it is also a what? Polygon. Correct. Now come to this one. This is not curve also. Simple curve also. This is not simple curve also. So forget about one. This is simple closed curve, but it is not a polygon. Why it is not a polygon? Because it is not made up of line segment. This is also a closed curve, but it is not made up of line segment. That's why it is not a polygon. Okay. And come to this one. Okay. You see, this is also a closed curve, but you see only 2 line segments is there, but this part is not a line segment. That's why it is not a polygon, and it is not a curve. Okay. So figure number 1 and 2. Figure number 1 and 2 are what? Polygon. Now come to convex polygon. Out of this figure, which one is convex polygon? So to draw a convex polygon, we need what? Vertices. Now you see here. If you draw the diagonal here, what is convex polygon? I told you already. Convex polygons means if you draw the diagonal, all the diagonals should lies inside the polygon. Then such type of polygons are called what? Convex polygon. Now you see the first figure. Here I am drawing one diagonal. This one. I am drawing one diagonal. This is one diagonal. This is one diagonal. These 2 diagonals lie inside. But if we draw this diagonal, if I draw this diagonal lies outside the polygon. That's why it is not a what? Convex. It is not a what? Convex polygon. It is a concave polygon. Okay. So it is not a convex polygon. It is a concave polygon. Now you see here this figure, whether it is a convex polygon or not. I am drawing the diagonal here. This is one diagonal. This is another diagonal. Okay. All the diagonals lies inside the polygon only. That's why it is a what? Figure 2 is a what? Convex polygon. It is a convex polygon. And what is concave polygon? Which one is concave polygon? This one is a concave polygon. Figure number 1. Okay. So I hope you understood how to classify the figures. Which one is convex and which one is concave, and which are simple curve, which are simple closed curve, and which are polygon. Okay. Now come to the question number 2 of this exercise. So okay. Now question number 2. How many diagonals does each of the following have? Means here some figures are given. Okay. This is first figure. This is a quadrilateral. This is a regular hexagon, and this is a what? Triangle. Okay. Now in this question, you have to tell how many diagonals you can draw here. Okay. So in a quadrilateral, you see this is one diagonal. This is another diagonal. Any more diagonals can you draw here? No, you cannot draw any more diagonals here. Okay. So only 2 diagonals. A what? Quadrilateral. What is diagonal? Diagonals means a line segment that joining the what? Opposite vertex is called what? Line diagonal. Now come to this figure, that is regular hexagon. How many diagonals we can draw? So I already draw the diagonals here. Here total 9 diagonals are there. 9 diagonals you can draw in a regular hexagon. You can try it. 9 diagonals. So in a in a regular hexagon, you can draw how many diagonals? You can draw 9 diagonals. Okay, total. Now come to the triangle. This is a triangle. Can you draw any diagonal here? Yes? No, you cannot draw any diagonal. So here 0 diagonal. Okay? Here Here you cannot draw any diagonal. So here in a triangle it is 0 diagonal. Okay. Now you see sometimes it is difficult for us. Means you may be puzzled to draw the diagonals, if the hexagon, pentagon, decagon, octagon. So for that case, you can find out the number of diagonals by using one formula also. I will give one formula. With the help of that formula, you can find out the number of diagonals very easily within a minute. No need to draw the diagonals again and again. If you know the formula, you can. If I ask what is the how many diagonals are there in a pentagon, you can very easily answer if you know the formula. Let us try to learn the formula. So if one formula is there, remember to find out the number of diagonals. So let us see number of diagonals. What is the formula? Number of diagonals. Formula is n into n minus 3 divided by 2. This is the formula, remember. N into n minus 3 by 2. Okay, here n is equal to number of what? Sides. N means number of sides. Suppose if you want to find out the number of diagonals in a quadrilateral, use this formula. You can find out very easily. So let us see for this case. N means number of sides. How many sides are there here? Here 4 sides are there. So is equal to n. In place of n, you can write 4. Then n is 4. 4 minus 3 divided by 2. So is equal to 4 into 4 minus 3, 1. So 2. 2 to the cancel. So is equal to 2. Yes, same answer you are getting. 2 yet. If you use the formula, you are getting 2. And practically when I am drawing, I am also getting 2. Means 2 diagonals in a quadrilateral. Let us check it for here. Okay. Now for what? Hexagon. So in hexagon, you know how many sides are there? There are 6 sides are there. So let us see for this one. Okay. N means what? 6. N means what? 6. 6 minus 3 divided by 2. So is equal to 6 into 6 minus 3. 3. So 2 3 is 6. So 3 3 is 9. You see 9 diagonals. So by using formula also you can find out the number of diagonals. Correct? Now come to the triangle. Let's check it. Okay. How many sides are there here in a triangle? 3 sides. So in place of n, what you write? 3. 3 minus n means 3. 3 minus 3 divided by 2. So is equal to 3 into 0 divided by 2. So 0 divided by 2 is equal to what? 0. Yes, 0 diagonals. So in a triangle, it is 0 diagonals are there, means no diagonals are there. So like this, you can find out the number of diagonals very easily if you know the formula. So you can find out how many pentagon. Okay, in a regular pentagon, how many diagonals are there? You can very easily find out without drawing. Also, you can find if you know this formula. All right. Now we'll go for the next question. That is question number 3. All right. I hope you know what is the measure of angle of a convex quadrilateral. Okay, means what is the measure of angles of a convex quadrilateral. So this is a convex quadrilateral that we have already learned. Convex quadrilateral means that quadrilateral means all the diagonals lies inside the figure only. Okay. So what is the angle sum property of this angle sum measure of convex quadrilateral? Suppose this is A, this is B, this is C, this is D. So angle A plus angle B plus angle C plus angle D is equal to 360 degrees. So angle, what is the measure of angle of a convex quadrilateral? Means convex quadrilateral ka 4 angles ko plus karne se, then you will get how much? You will get 360 degree. Okay, so that is the first answer is what? 360 degree. Now second part, you see what it says. Will the property hold if it is not convex? Okay, means whether in a concave quadrilateral, means if the quadrilateral is not a convex, then whether sum of the 4 angles is 180 degree or 360 degree or not. Okay, so let us try whether it is 360 degree or not. Now you see here I am drawing one convex quadrilateral, whether it is a quadrilateral or not. Yes, it is a quadrilateral. You see, 1, 2, 3, 4. 4 sides are there. Okay, 4 sides means it is a quadrilateral. Okay, so if it is a quadrilateral, now we have to check it. We have to check it whether all the angles. Now you see how many angles are there. 1, 2, 3, 4. 4 angles are there. Whether sum of these four angles of this convex quadrilateral is 360 or not. Okay, so we have to see. Let us see whether it is correct or not. A, B, C, D. So now for checking what you have to do, you have to divide this concave quadrilateral into two parts. Okay, correct? Understood? Now suppose the name of this angle is 1. This is 2. This is 3. This is 4. This angle is 5. Correct? Now you see, here we are getting two triangles. When I split this non-convex quadrilateral, you see, why it is not convex? Because if you draw this diagonally lies outside of this quadrilateral. That's why it is a what? Concave quadrilateral, not convex. Now we have to check it whether all the four angles measured is what 360 degree or not. So for that, what I did, I split this non-convex quadrilateral into two parts. I join these two DB I join, then it divide into two triangles now. So this triangle and this triangle. So in triangle ADB, angle 1 plus angle 2 plus angle 3 is equal to how much? You know, it is a triangle angle sum property, 180 degree. Again, count to angle in triangle DBC. In triangle DBC, angle 4 plus angle 5 plus one more angle is there, 1, 2, 3, 4, 5, 6. One more angle is there, 6. Angle 4 plus angle 5 plus angle 6 is equal to 180 degree. This is equation number 2. Now add equation 1 and 2. Let us, what we are going to do, we are going to see whether sum of the four angles of a non-convex quadrilateral is 360 or not. Okay, now we got two equations, left side you have, right side you have. Angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 is equal to, here 180 is there, here 180 is there. Okay, correct? Now angle 1, write down, angle 1 plus angle 2 and 5 you make group, angle 2 and angle 5, angle 2 plus angle 5 you make one group. Okay, plus angle 3 and angle 6 you make one group, angle 3 plus angle 6. Okay, then now this angle left now, angle 4 plus angle 4. Okay, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Correct? Now is equal to, here how much I get? 180 plus 180, 360 degree. Okay. Now angle 1. Angle 1 means what? Angle A plus angle 2 plus 5. You see, if you add these two angles, you will get what? Angle B. If you add 3 plus 6, you will get what? Angle D. And angle 4. Angle 4 means angle C is equal to what? 360 degree. Means what we came to know after doing this much calculation? We came to know that sum of the angle of a non-convex quadrilateral is also what? 360 degree. Means will the property hold if quadrilateral is not convex? Means if the quadrilateral is not convex, whether sum of the angles of the non-convex quadrilateral is 360 or not? Your answer is what? Yes. What? Yes. Correct? And that is the reason why it is yes. Okay? I hope it is clear to you. Now we will go for the question number 4 of this exercise. So now come to the question number 4. You see, here some figure, one table is given in that question number 4. It is a triangle, this is a quadrilateral, this is a pentagon, and this is a hexagon. So here, you know what is the angle sum of the measure of 3 angles of a triangle? It is 180 degree, and sum of the measure of 4 angles of a quadrilateral is 4 angles. Measure is sum of the measure of 4 angles of a quadrilateral is 360 degree. Okay, and in pentagon, if you add all the 5 angles, 1, 2, 3, 4, 5 angles, if you will add, you will get 540 degree, and if you will add all the 6 angles of an hexagon, you will get 720 degree. So here some relations are given. Okay, angle sum properties, some relations between the side and the angle is given, and by seeing this pattern we are going to derive one formula, angle sum property. Okay, with that angle sum property formula you can find out the sum of the measure of any polygon very easily. Okay, so let us try to see the pattern here, and we will try to derive one formula of angle sum property. Now you see, three sides angle is what? 180 degree. 4. This is quadrilateral, 4 side. Okay, so you know the sum of the 4 angles of a quadrilateral is 360 degree. So 360 degree, can I write 2 into 180 degree? We can write what? 2 into 180 degree. And these 2 I can write 4 minus 2, because 4 minus 2 is 2 into 180 degree. Now use this, you see this 4. If side is 4, the 4 will come here. Okay, now here the angle sum property of a pentagon is 540 degree. This 540 degree you can write 3 into 180 degree, correct? 3 into 180 degree. And this 3 you can write 5 minus 2 into 180 degree. And this is an hexagon. Hexagon sum of the 6 angles is what? 720 degree. This 720 degree you can write 4 into 180 degree. Okay, 4 into 180 means 720 only. Okay, now this 4 you can write 6 minus 2, correct? This 4 you can write 6 minus 2. Now you see, when you see here, you will observe some pattern here. This 4 means if side is 4, 4 is coming. Here side is 6, 5 is coming. And here side is 6, so here 6 is. Other things are, you see, 180 here also there, here also there, here also there. And minus 2, minus 2, minus 2, everywhere minus 2 is there. Okay, only the differences is if the side is 4, 4 minus 2. If side is 5, 5 minus 2. If side is 6, 6 minus 2, like this. So if the side is n, then if side is n, if side is n, then how you can what will be the formula? By seeing the pattern you can write. Now see, if side is 4, here it is coming 4. Means here I am telling if side is n, so in place of 4 you can write n. Other thing is same, n minus 2 into 180 degree. Means angle sum of polygon, any polygon, angle sum of any polygon you can find out by the formula n minus 2 into 180 degree. So this formula, if you remember, you can find out the what? You can find out the angle sum of any polygon. So let us try to do one question from this question number 4. That is, what can you say about the angle sum of convex polygon with side 7? If side is 7, okay? So let us try to do one question. If side is 7, what will be the angle sum? So our formula is n minus 2 into 180 degree, angle sum. Okay? So question number 4. So angle sum formula is angle sum is equal to n minus 2 into 180 degree. So we derive this formula now. Okay, n minus 2 into 180 degree. So n is equal to number of what? Sides. Number of sides. Now the question number 1, A, what is say? What can you say about the angle sum? Okay, if side is what? 7. A. If side is 7 means 7. How many? Means if the polygon have 7 sides, what is his angle sum? So n is equal to 7. So we can write what is the formula? N minus 2 into 180 degree. So is equal to n minus 2 means what? N is what here? 7. 7 minus 2 into 180 degree. So is equal to 7 minus 2, 5. 5 into 180 degree. So 500, 5 into 8. 5 is the 44. 5 is the 5 plus 4, 900. Means if the polygon have 7 sides, then angle sum is what? 900. Means if the polygon have 7 sides, what is the name of this figure? This is called heptagon. This is called what? Heptagon. In heptagon, angle sum, if you add the 7 angles, okay, in heptagon, if you add the 7 angles, you will get what? 900 degree. Okay, 900 degree. Let us try one more question. Okay, that is the next question. Next question is 8. 8 means what? Octagon. 8 is equal to side. How many sides now in this polygon? 8. So 8 means what? Octagon. So what is the angle sum of octagon? Means if we add all the 8 angles of an octagon, then what you will get? 8 is equal to n. So is equal to n minus 2 into 180 degree. 180 degree. So n is 8. 8 minus 2 into 180 degree. So is equal to 8 minus 2. How much? It is 6. 6 into 180. So is equal to 600. 600. 6 is 48. 4. So 6 plus 4. 1080 degree. Means if we add 8 angles of an octagon, this is 8 is equal to n. It is sides. 8 side means octagon. And if it have 8 side means it has how many angles? 8 angles only. If we add all the 8 angles, you will get what? 1080 degree. Okay. So I hope it is clear. So remember these two formula we have learned today. One is now how we can find out the diagonal of a polygon by formula. What was the formula? N into n minus 3 divided by 2. And the second formula we got here angle sum. How we can find out the angle sum? We can find out the angle sum by the formula n minus 2 into 180 degree. Okay, so that much for today's class. In the next class we will try to do question number 5 and question number 6. So thank you for today and have a nice day.